So remember when we were calculating the basketball shot last time without the drag, we used the equation s equals ut plus a half at squared. So this is why I decided to, for this, when we're doing it with drag, we will also use the equations with s in them. So we have all this information. We know that for a basketball, k will be 0.31. I'm going to trust the terminal velocity I found online instead of the one that I calculated, because the online one's probably right. And the mass is 0.625 kilograms. So if we start off in the x direction, so we can just bring it up here. So we have s of x is 27.2 equals, so m is 0.625 times u cos theta. Well, that's the initial velocity. That's one of the things we're going to solve for. So that stays as u cos theta. All divided by 0.31 is k for a basketball, multiplied by 1 minus e to the minus, and then we have 0.31 times the time taken was 2.57 seconds, all over the mass is 0.625. Okay, so now we just need to figure out what this is. So we have which means that 4216 over 225 equals u cos theta. So that's our first equation for now. Now we're going to get an equation for the y direction. So s of y is 0.94 equals, okay, this is going to be very messy, 0.625 squared So second equation with u and theta. I'm just going to bring the other one down so we have them together. So now we can solve for u. We can solve for u in the left one. So we get 15.87 all over sine theta equals u, and we're going to plug that into this. So we get 4216 over 225 equals 15.87 over sine theta times cosine theta. So we get 1.18 equals cos theta over sine theta, which means that we can get tan by taking the reciprocal on both sides. So that gives us 50 over 59, because it's recurring decimal, equals sine theta over cosine theta, which is equal to tan theta. Therefore, theta equals the tan inverse of 50 over 59, which is approximately equal to. So we find that the angle he threw it out now is 40.28 degrees. But interestingly enough, when we calculated the first time, we got 50.66, so that's a 10-degree difference when we took the drag into account. Now that we know this, we can find out what u is. I'm going to take this one, because there's no fraction. 15.87 equals u times sine theta. So sine of, we know it's about 40.28. So it means u equals 15.87 over, sine of 40.28, which is approximately equal to 24.55 meters per second. So it's actually faster than last time. Last time we calculated about 17 meters per second, so this is way higher. So I don't know if this is actually a worse approximation or a better approximation, but either way, we took the drag into account. Maybe if we took quadratic drag into account instead of linear drag, maybe we'd be closer to what we originally got, because I think 20 seems a bit high. And if we also took the spin of the ball into account, maybe we'd get an even more accurate answer. But for now, I don't have time to do all of that, so this is what we got. We said no air resistance, it would go at 16.76 meters per second at an angle of 50.66 degrees. And with drag, the initial speed was 24.55 meters per second, and the angle is 40.28 degrees. So that's it. I'm not going to be doing any more, but thank you very much for watching, and I hope you enjoyed.